When a force brings an object to a stop, it causes the object to lose all of its momentum. Now, momentum is the product of an object's mass and velocity. So to bring one to a stop, we need to make it lose all of its momentum. Let's suppose someone has just fallen from a large height, and as they land on the floor, they suddenly stop. This causes them a lot of pain. But why? Well, to understand this, let's remind ourselves that the resultant force acting on an object is equal to the rate of change of its momentum, or algebraically, F equals delta P over delta T, where this delta symbol means change in. So if the person has stopped, the change in momentum is their momentum decreasing to 0. If this change is sudden, then this implies that the time taken is incredibly short. So delta P is large and delta T is small, meaning that overall F is incredibly large. Such a large force acting on the person's legs is dangerous, as it can damage the bones in them. But what exactly can we do to make this landing safer? Well, the longer it takes the object to stop, the smaller the force needed to do so. So let's consider the person falling again, but this time they bend their knees as they land. By doing so, instead of stopping suddenly, they slow down gradually. This means it takes longer for them to lose all of their momentum, which then reduces the damage in their legs. But why? Well, let's think back to our force-momentum equation again. If the person falls from the same height, the change in momentum would be the same. It's their initial momentum decreasing to 0. But if it's taking longer to lose this momentum, then the time taken must be larger. As the numerator of this fraction is larger, the force must be smaller. So there's less average force acting on the legs as the person lands, reducing the damage done to them. They could spread out the change in momentum even further by rolling instead of just bending their knees when they land. But let's look at some technologies that make use of this principle of increasing the time to stop. Most safety equipment is designed to increase the time it takes to stop and reduce the force causing this. On the left, we have a bicycle helmet, the inside of which is cushioned. If a cyclist's head is hit during an impact, this makes the impact and the change in momentum last longer, resulting in a smaller average force which does less damage. The same principle applies to other protective clothing like shin pads and arm guards. Then on the right, we have a gym mat, which is made from a soft material that compresses when someone lands on it. This means the reaction force from it lasts longer, so there is less average force bringing someone to a stop. You'll also find mats similar to these in playgrounds or in athletics fields for high jumpers and pole vaulters. For your exam, you need to be able to recall these examples of safety equipment and be able to explain how they work.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!